This is a conversation with Dr. Günther Kletetschka. He's a physicist, geologist, and world expert on magnetism. He spent his career chasing mysteries across some of the most remote places on our planet. Günther's worked with NASA, studied impact craters from Siberia to Bolivia. He's written papers on ancient catastrophes, the magnetic field on Mars, and the human brain. His work is often on the invisible forces that shape our world, from the Aurora Borealis to three-dimensional time. We had the opportunity to spend some time with Günther. In the frozen expanse of central Alaska, he showed us ancient lake core samples, a special built room that removes your magnetic field, and much more. Günther is an incredibly deep thinker, yet he's an artist and a creative at heart who follows curiosity wherever it leads. The conversation takes place in a yurt in the Alaskan winter, deep in gold country, where mammoth bones poke out of the permafrost and grizzly bears and wolves linger just out of sight. It is here that Günther studies the Earth's magnetic field and the northern lights that paint the sky. We are very much at the ends of the Earth, and very much in his element. Can you tell us a little bit about where we are right now?
Hey, we are in a beautiful site in Alaska, in central Alaska, and what I like about it that this is actually the place that you read from like a Jack London that people were looking for gold, and this is actually the place where the gold was found. So if you just dug underneath this place, I'm sure you would find little flakes of gold. So I feel it's very fortunate.
Deep in the hills of central Alaska.
Yeah.
If somebody's not familiar with your work and your expertise, this is a bit of an impossible question because you do a lot of different things. But how would you describe what you've spent a lot of time studying?
Well, probably the most easier thing is the most natural way how when people get born, you always have some mystery things about some secrets and you are trying to figure that out. So I think that's what drives me. And sometimes because I studied physics and mathematics and then geology, so I'm trying to wrap myself in a realm of secrets that has to do with the geology and physics and sometimes mathematics. So it's just that you are trying to figure things out, like does it make sense? And then what I like about being here, that you have freedom. You are free to think of anything. No one will really constrict you to think like a certain way. And so that freedom is really important.
When you say here, do you mean in the United States or in Alaska?
No, in general, once you get born, I mean, even if you are in some constricted nation, you still, are free to think whatever you want, right? Even though you may not say it out loud, but you can still think that way.
Right. It reminds me of the book, A Man's Search for Meaning. Have you read that before?
I don't think so, but it sounds like it must have been a good book.
Yeah, it was very impactful for me. It's Man's Search for Meaning is a book about somebody who survived the Nazi concentration camps. And it's a narrative of all the things he saw. But kind of the through line is that you can take away every instance of my life, every bit of freedom I have, but you can't fully take away my mind.
Well, it touches on the consciousness issue and what's the meaning of life and all these philosophical things that are sometimes very difficult to talk about and can mislead us in various ways.
And I want to get into that, but it'd be helpful if we set the table with some context. I know that you've studied many things, one of which is magnetism. And so help me understand the connection between magnetism and Alaska. Why is this place special in that way?
Well, it's a very good question. And Alaska is very close to the North Pole in terms of, we are very close to the polar circle. And that's where all the magnetic flux lines are focusing. So you can also imagine like a flower start from being very narrow and suddenly spreading out, like flaring up. And that's what the magnetic field in this environment look like. And you are familiar that there are these like northern lights that have always this like a magical circle. And so you wonder why there is this circle, why there is nothing inside the circle. And that has to do with the intensity, like a magnetic intensity in that circle. And the magnetism always like inspired me because it was like an invisible force that you cannot really touch too much, but you can still experience it by just having a magnet in your fridge. And that captured me, and I was thinking maybe there's something really special. And even if you talk about like Steve Hawkins, he said there are like three important things in this world. There's a mass, a rotational moment, and electric charge. And electric charge is definitely connected with the magnetism, because as soon as the magnetic charge is moving, you get the magnetic field.
So Earth has this magnetic field, and then you're explaining how the northern lights connect to that. So what exactly are the northern lights?
Well, there are northern lights and southern lights on both poles, and it's people dream about it, because when you are in the middle of Alaska just looking up there, you suddenly see, oh, there is some greenish and reddish, and you start staring on it, and you suddenly see like a little whale of lines, and these whale of lines are actually visible magnetic field lines, like a flux line. So you can actually see the magnetic field using the northern lights. And then you keep looking at it, and suddenly you see it's dancing. Suddenly the red color will change to green, and green change the shape. And so you wonder what's going on. And everything is connected with the sun, because if there would be no sun, we would have no northern lights or southern lights. The reason why it is that the sun is, our source of energy. It's just a central part of the energy which is being delivered in form of radiation, but also in terms of the packets of energy. And what's packet of energy? Why sun would be throwing at us packets of energy? It's like a ball of fire which has a very peculiar, like a magnetic field lines, and there is almost like a magical process that once you get reconnected these magnetic field lines, you suddenly can accelerate vast amount of ions away from the sun. And when these ions are interacting with the magnetic field, because they are all charged, mostly positively but also negatively, then you get this effect that we see as a northern lights. There's a little more detail into it, that how it's being done, and it has to do with the same process that we started with, meaning how the energy was expelled from the sun. Because the same process, when you start interact with the magnetic field of the Earth, then you have this reconnection of magnetic field lines. And once you get it, you can always imagine what is reconnection of magnetic field lines. It's like when you have a slingshot, you have this rubber band that you stretch out and release. And the same thing is happening with the magnetic field line, that when there's reconnection, it's like that release of the slingshot, that suddenly that magnetic field lines is racing to make a most simple geometric form. And as it does, it accelerate all ions which are nearby to speed that sometimes can reach fractional speed of light. And so once you have these ions that are like falling along the magnetic field lines, where the magnetic field lines are ending up, in the North Pole or South Pole. And that's the reason, right? Because you are taking all these ions, accelerating towards the North Pole, but then they start to collide with the atmosphere, and that's where the magic happens. You get these like a beautiful northern lights that are changing because there are different packets of energy that were accelerated from either from the geomagnetic tail or from various region in a magnetic shield, which we call like a magnetosphere.
So it's fascinating. So it's this energy that's coming from the sun, interacting with the Earth's magnetic field, and then you describe it kind of burning along these lines. Maybe burning is the wrong word, but getting destroyed along these lines and collapsing on the North and the South Pole.
Yeah, it's not burning, it's just a spinning.
Yeah.
Ions are spinning, and because it's vacuum, there's nothing to, slow them down. But then when you get closer and closer to the Earth's atmosphere, now there is oxygen particle or hydrogen particle, like a part of the atmosphere, and that's is being ionized as there's a collision of those ions with those particles. Number one, you create ionosphere, and number two, you create the northern lights or southern lights.
Are there northern lights or southern lights on other planets?
Well, you pick up the topic that has to do again with the magnetic field. We know that here on Earth we have this geomagnetic field, right? And we know that in a way the geomagnetic field is like a little capsule that keeps us safe from the sun. And so now you have to think about, do other planets have magnetic fields? You go Mercury. Oh, there is some in Mercury. So you would expect that Mercury may have some effect of northern lights, but Mercury doesn't have too much atmosphere, which means that you would not have that effect because you would not have this deceleration where you would get these northern lighting. However, it's well known that, for example, Jupiter, that has a giant magnetic field, has the northern and southern lights that were imaged by various missions that were flying by Jupiter.
Wow. So what caused the magnetic field in planets in the first place?
Oh, that's a very important question, because even Albert Einstein said once we discover the reason why we have a geomagnetic field or planetary magnetic field, it will be like a big discovery. And this is to me a little bit controversial topic, because my view is different than the general wisdom, and it has to do with the core, because we know that every planet usually heats up itself. It has to do with the radioactivity, and because at the beginning there was a radioactive material inside each of the planetary bodies, and because it was releasing heat, it slowly accumulated the heat inside. And as the time went, there was so much heat that you started to melt the interior of the planet, creating a core. And when you have a hot material, you want to release that thermal energy, and the most convenient way is through the convection. So the hot material, which is like a lower density, it has a tendency to go up. It has to do with Archimedes law, right? Because once you have something that has a very low density in the water, it just goes up. Same thing like when you have something in a core which is low density, which is a hot material, it just wants to go up. And so this way you are taking the heat from the core and pressing it away to the boundary of the core and the mantle. But what's remarkable is that there is a rotation, which once you think about this process of moving some material from the inner of the core to the outside in a rotating body. There is a thing called Coriolis force, and everyone who is watching like a weather forecast is familiar with this, because you can see those pressure highs and pressure lows of the atmosphere, how they are circling because of the Coriolis force. But not many people are thinking of the same process in the core. That in the core there has to be also like a pressure highs and pressure lows, but it would be the like a high density or low density liquid that would be spinning and making like little spirals around the rotational axis. And so another thing that I found exciting is that if you have a fluid which is spinning and you have this convection cycle, there is a physical reason why you don't have a mixing between the northern hemisphere and southern hemisphere. Meaning that if you, for example, have blue northern hemisphere liquid and red southern hemisphere liquid, the two fluids would not be mixing, because there is no force that would be pushing like the blue one into the red and vice versa, which makes an interesting analogy that what I'm trying to do is to explain the geomagnetic field and how it is formed. And the way I think about it is that you have this spiraling motion of the hot fluid, which is high conductivity, which means it's like a spiral of the wire. If you imagine like wires in the northern hemisphere, and you have an electric current going along these wires, you get what? You get the dipole magnetic field out of these spirals. But that's the northern hemisphere. Now the southern hemisphere, because of this rotation, there is a opposite motion, meaning that the same hot fluid would create a coil, like a copper coil, it would be directed the other direction. So in this way, you would have like one dipole in the northern hemisphere pointing upward, and in the southern hemisphere, another dipole going downward. So I imagine like our geomagnetic field as a fight between the northern hemisphere activity and southern hemisphere activity. And whoever wins is the polarity, which is present, meaning right now we have a so-called normal polarity, which means that we would have a southern hemisphere dipole that would be winning.
And so, you kind of alluded to something there, which is that it's not always been that way, right?
True, right. There was always this fight, like there's a fight between evil and good.
Right.
There's a fight between the northern magnetic polarity and southern magnetic polarity. Southern, it's like an arrow, right? The magnetic field, when you have a compass needle, it's like a compass arrow that is pointing to the north. And so right now, the polarity, if you imagine our Earth as a giant compass, is a magnetic needle is pointing to the south. So if you imagine that arrow, and we call it normal polarity, in the past, like 800,000 years ago, it was actually pointing upward, and we call it reverse polarity. And so in my view, it looked like that at that time, it was the northern hemisphere that had more activity, and therefore it was more winning to create this specific arrangement of this arrow pointing in the other direction, pointing upward. And the question is that this fact that we have a magnetic reversal in the history allows us to use it as a very interesting tool for chronology, because we know that some of the material which is being created on Earth has been created at the time when there was a specific geomagnetic field. And so if we go 800,000 years earlier, then all the basaltic rocks that were created during the volcanic eruption or whatever would be pointing the other direction than if they would be created later after 800,000 years. And before 800,000 years, this magnetic reversal had much faster frequency, because right now it took 800,000 years and we still have this normal polarity. But before that, the magnetic flipping was occurring approximately every 100,000 years. And so people are wondering, why is it? Why there is such a lack of magnetic reversal, at least in terms of the evidence that we see. And so people wonder, was there anything special that happened maybe 800,000 years ago that was not happening before that kind of like make this polarity more stable? And it's a mystery.
It's a mystery. And we talked about this a bit yesterday. There is something that happened 800,000 years ago, right, that we have evidence of. Can you tell us a little bit about that?
It's a kind of association, meaning it doesn't have to be directly connected, but what happened at that specific time frame was that there was, when you look at the ocean cores or sediment or any kind of a sedimentary record, you find that approximately at the same time when there was this last magnetic reversal, there was over the 1/3 of the surface of the Earth, there are tektite deposits. Those tektites are called Indochinites. Tektite, it's a strange word, right? So tektite is like a glass, like when you have a beer glass, when you break it. So it's like a tektite. However, this tektite is special because it was formed at very high temperature. If you analyze it, you see there are indicators that there has to be temperature increase more than 2,000 degrees Celsius. And so the current understanding is that the tektite is formed during the meteorite impact or some kind of impact. And so when you have an impact, right, so you have an object, and the object is speeding through the space, but now suddenly it's being decelerated by the Earth's atmosphere. And depending on the size, I mean, it matters or it doesn't matter. If it's big, then it doesn't matter that this atmosphere just goes straight to the surface. But what's interesting is that, on the leading side of this impactor, you compress the air. The air that we breathe, it's compressible, meaning that you can compress it to very high pressure. And that there's a law in physics that says that once you increase the pressure, you also increase the temperature, right? The temperature gets really hot just on a leading phase. And so when it's going very close to the surface, now that really high temperature is capable of melting the surface material. So if there is, for example, loess deposit or any kind of a sandstone, you would melt it and make a little like a puddle instantly, because number one, there is a radiation, because it's just shining right everywhere, because you are decelerating and all that heat is translated to the light. And so not only the light, there is this very high compressed air, which is really hot. And so these two affect the soil in front of it, that instantly make a pool of liquid. And that liquid, because there's high pressure, just spewed out or like ejected out into the air. And then it usually covers the huge area in the forward direction over the impactor. And so that's how we think that the tektites are formed. And so the well-known tektites are like Moldavites in the Czech Republic that are known that they were, the Reese crater was a meteorite impact that was responsible for creating those tektites, that when it was coming down, it just melted the pool of limestone, and that molten limestone became a glass that was ejected towards Czech Republic and covered most of that area with the glassy, beautiful, gem-like looking tektites. And however, when we talk about this 800,000 year event, it's just totally surpassing this, like a small event that created the Moldavites, because in terms of the material, the Indochinite, that are also glass-looking things similar like Moldavites, they are like 4-5 orders of magnitude more abundant. You can find like a large pieces of glass, and not only over the China and over the India, but all the way to Australia. So it looked like it was a huge process that created very large volume of molten material that went into the air. And not only into the air, people think that went all the way above the atmosphere and was out in a space, and then was actually coming back down, like in Australia, back to the ground. So so we have evidence that something happened that created these glasses, these Indochinites. But then you think, okay, so we have a tektite, so we just, where is the crater? And that's another secret or mystery, because we don't know where the crater is. In Moldavites, it's clear, it's a Reese crater, and we have Moldavites. But in Indochinites, where is the crater? There's no hole or anything. So there is many ideas that maybe it's in China, maybe it's in Laos, maybe it's somewhere in that area, but we don't really know exactly where it is. So that's make it curious. And the reason why we are talking about it, that just like if you look at the sediment, you found the tektites in the ocean, right? In the ocean is like a treasure chest of the material. And so you look, okay, now there's a tektite layer. And now you have a sedimentation, tektite is covered by more mud. And it looked like that less than like 2 feet of mud, suddenly the magnetic field reversed. And so there is like a cause and effect, right? That there's a tektite, and maybe the energy that was used for creating this mass amount of tektites was responsible maybe for magnetic reversal. But it's a speculation, and no one really can connect how exactly would that happen.
Interesting. So something hit the Earth.
Something created a lot of Indochinites.
Okay. So we don't know. I guess we don't necessarily know that something hit the Earth, but in other evidence, like that's That's one working theory, right?
Yeah.
And then from that, there's this huge explosion of the material, and then right after that, geologically speaking, a thousand years, the entire Earth's magnetic field flipped for the last time in 800,000 years after it had been flipping on a 100,000 year roughly basis before that.
Right.
So you're like, I don't know, maybe these things are connected, right?
Maybe they are, maybe they are not, but it's
Right.
an interesting correlation of the events that happen. And also people think there was during the last 800,000 years, there were about 10 events that the magnetic field wanted to reverse, but they didn't finish it. So there's a well-known a record that the magnetic field was suddenly migrating to the south, the north magnetic pole to the south pole, but then it didn't stay and just went back to the northern side, to the normal polarity. But so there's this event was recorded, for example, in one of the trees in Australia. And, in Australia, some of the trees are huge and have a lot of tree rings. And so interestingly, there was a record that some of the tree rings had a reverse polarity. They had a normal polarity, but you could see in the rings that there was this attempt to get the reverse magnetic field. And so this was a recent paper that was published, and that showed that during that event, it looked like that there was quite a significant environmental change, that lack of magnetic field caused a disruption of the way how things were happening at that specific time.
Help me understand if, let's say, for instance, because we don't really know fully what would make it switch, I guess, right? We have ideas of how, but it hasn't switched. If the magnetic field did switch, how would that affect us? What would be the things that we would be aware of that would change?
Well, again, based on mostly sedimentary record, people are studying not only the direction of the magnetic field, but also the intensity. And it became clear that once you have this magnetic reversal, you lose the geomagnetic intensity. And so the field during the magnetic reversal is maybe order of magnitude lower than it is during the time of normal or reverse magnetic field, and which means that the magnetic field is serving like an umbrella, right? It's shielding us from the things that are happening outside. And what are the things happening outside? It's the sun and it's the Milky Way. Those are the two most important significant sources that are causing our environment to change. Sun is quite clear, right? I mean, every day we experience the sun. The Milky Way galaxy, or the center of the galaxy, is not that clear. But what it is that we know that the sun has a solar cycle. Though this is like an 11-year period where there is a magnetic polarity going one way, and it switches after 11 years to go the other way. And those cycles are connected with the appearance of the sunspots. And usually when you see sunspots on the sun, that means that the sun is really energetical. It's really have a lot of energy and it's more active. But when you don't see sunspot, it's usually the period when it's not as much active. And it's interesting that we know that around the whole our planetary system there is a also magnetosphere that is caused by the sun. So it looks like a similar umbrella that is around the Earth. There is a similar umbrella around the whole our solar system, and that umbrella is deflecting the high energetic particles from the central galaxy, so the so-called cosmic radiation. And so now when there is a lower intensity of the sun, that umbrella weakens, and therefore there is more cosmic radiation coming in, and we can experience it in some of our detectors, because some of the high energetic particles can actually be shown like in crystals of some minerals, and they can penetrate the whole geomagnetic like a shield, as well as the solar field, the solar shield. And so this tells us that when there is a magnetic reversal, you also have a weakened geomagnetic field, and therefore there is more energy possible to come in, and that could cause like a mutation, or because there's a radiation environment suddenly becomes higher by order 2 orders of magnitude, which means that there will be more so-called damage of the DNA. Every living species has a DNA which is like a double-stranded, like a spiral, but the high energy radiation can snap it like a scissors, and then it's really difficult to reconnect. And because of the difficulty of reconnection, you can get a mutation of these cells, which could cause extinction of certain species, but also of creating new species as a result of mutation.
And then on the human side of things, if I'm not mistaken, it increased cancer rate.
Of course, yeah.
So
the cancer rate is a failure to divide, and so once you have four specific conditions in a cell that are normally working in a division, then you get cancer. And because one of the condition is to have a consistent like a DNA, and if it's compromised, then you have a higher likelihood for cancer growth.
You were talking yesterday about how this mechanism of having a lack of a magnetic field and its relationship with an increase in radiation from the sun may be involved with the beginnings of life on Earth. Can you tell us a little bit about that?
It's a very interesting story, because we know that when we think about geomagnetic field, many people don't think about it at all, right? But only when they have their iPhone and say, oh, there's a compass needle, and they start thinking there is when you have a magnet, right, on a fridge. But the geomagnetic field was not here all the time. Like when the Earth was starting to form, it looked like that maybe it was absent, but was created very shortly after the Earth formation, and maybe also had to do with the Moon formation. But I don't go into detail, but we know that the Earth is 4.6 billion years old, right? Somewhere, let's say, around 4 billions, that we had a magnetic field, which was like created this protection, shielding against the sun, and was always, based on the record, about the same, like a tenth of so-called microtesla, which is a unit. Today, if you would look at that intensity that penetrate everything where we live, it's between 30-50 microtesla. So it was always on the similar level. However, based on the record, at about 600 million years, this geomagnetic field lost its strength. It's almost disappeared. And so the rock from that period of time, if you just measure, they have no magnetism. Because normally everything, if you even take your beer bottle, or if you if you have a little like a ceramic pot, everything has an invisible aura, magnetic field, because it was formed inside this known geomagnetic field. But if you would make your ceramic pot from the material that was formed 600 million years ago, then the aura would be just missing. I wonder, why is that? What happened, right? And so that's another mystery that we don't know. We only know that it just disappeared and then reappeared maybe 10 million years later. There are hypotheses that maybe have to do with the formation of the inner core, because the Earth is like a ball, right? And when it's cooling down, it releases the energy. And if you have a core which is liquid, when the liquid is cooler and cooler over the time, suddenly you start solidify some of the liquid, and that was the formation of the Earth's core, inner core. And now, before that, you had certain, convection pattern. You were releasing the heat from the center, and you had the certain of these, like a spirals that we were talking about, that are responsible for creating this dipolar magnetic field, which somehow is fighting, like over the ages to get these magnetic reversals. So now, at the people think, or there is a hypothesis out there that because there was a formation of this inner core, it collapsed or compromised the convecting floor responsible for geomagnetic field, and therefore it disappeared for a few million years until the new set of flow releasing the heat was set into the core, which recreated the dipole magnetic field, and again the magnetic field strength went up. But to answer your question, how did it? What was the effect on the life on Earth, right? And so 600 million years ago, there is this special period called Ediacaran explosion of life. Ediacaran explosion, how life could explode. Explosion is not necessarily like a damaging. It could be just, spreading. It's when you have yeast in your bread, suddenly you have so much growth of the yeast that it's like explosion of the yeast in the bread. So something like that happened in the ocean, that you had all these like a simple, like a unicellular or simple multicellular organism that were just, floating, and they were not really defined like a shape of the bodies. Like we know, there are some organisms that have a head and tail, and that thing was developed during this explosion of this Ediacaran explosion of life. And so we think that the reason was this absence of the geomagnetic field, because once you have no geomagnetic field, therefore all the radiation from the sun and also cosmic radiation is all affecting your environment, and all these radiation is directly hitting the atmosphere, the column of the atmosphere. And then if you are living in the ocean, let's say you assume you are like a little organism, right? Now you are being hit by more UV radiation and other radiation types, meaning that you start you want to divide because you feel like you need to divide, but suddenly your DNA is compromised, and your DNA, maybe I should not divide normally. I would do, little other things. So suddenly you have a very large diversity of the life form in the ocean. And it looked like at that time there was a winning form which preferred like a head and tail. There was this first symmetry that was forming during that time that then was continuing until the Cambrian explosion of the life, like a fish and trilobites and all these plants that were developing were part of this process.
So is there other times in the history of the magnetism of Earth where we see a similar thing where we're like, it's not tracking anything, it's a zero? Or is this a very unique and special time?
It's a very unique and special time because we don't see it anywhere else. We see like a magnetic reversal,
right,
which is short time scale, and the field does not disappear as bad as during this specific episode, the Ediacaran time. Because normally during the geomagnetic reversal, let me try to be a little technical, dipole has two poles, right? But people know that magnetic field can exist also as a multipole, like a quadrupole or octupole. And so when you analyze the way how the geomagnetic field would be reversing, then it looked like that the dipolar component will be the one which will be diminishing almost like order of magnitude, while this other, like a quadrupole component, would start to be dominant. Not that they would necessarily increase, but because you decrease this dipolar topology, suddenly you have this quadrupole. How do you imagine quadrupole? Quadrupole, for example, if you have two magnets, right? They can kind of connect like above each other, or they can like connect if you go antiparallel to each other. And if you put them like antiparallel, so one magnet is pointing one way and the other downward, this is the quadrupole. So you can imagine that there is this quadrupole like a component of the Earth which would be winning during the time of the magnetic reversal, and so there will still be some magnetic field protecting as opposed to this Ediacaran episode.
Wow. Okay. Well, that makes it extra bizarre. One of the things I think is really fascinating talking to you about magnetism is it's like this invisible world. Like it's almost like you're looking through like a heat map, right? It's like you're seeing the world in a way that's just as true, but in a way that I think for me and for most people, like you don't think of it every day. You're not thinking about how we're constantly interacting with magnetism in different ways in the devices and the world around us. And one of the things I thought was fascinating when you showed us your laboratory was the map of the Earth, but on it was color coordinated all of the different areas of high magnetism and low magnetism. So can you talk a little bit about that? What drives high magnetism and low magnetisms on different places on the surface of the Earth?
It's a good question. We were looking at the just global magnetic map on the Earth, and so we noted, for example, the bands on the oceanic floor, because the oceanic floor is spreading, and so each time when the magnetic field reverses, suddenly there is like a different, like a band of the lava flow at the bottom of the ocean that has a reverse polarity. And so because of this continued process of formation of the oceanic floor, we saw the striping at the oceans as opposed on the continents that were more like a randomized, chaotic, like a high energy versus low intensity magnetic fields. Now, in general, the magnetic intensity is driven by iron. That if you have like a more iron density, then most of the time you also acquire larger magnetic intensity. Even though it's not always true, but most of the time, when you see really hot spot of like a red or hot spot of blue, then you would think if I would go there, it's quite likely that I would have a more iron in a process in that geology environment. And so that's one thing, and another, and that's connected with the kind of energy environment, because very often when the geology is colliding or making friction, that the heat which is being generated almost always is creating like a magnetic mineralogy. Because iron can be in a rock, but the iron would not be magnetic. But once you have this heat associated with the collision or deformation, very often that results in formation of very often magnetite or titanium magnetite. Those are the minerals that make these color very intense, like a red or blue.
So it's a combination of what the geology is, and then the history of that geology interacting with heat.
And what's good thing about this magnetism, that for example, if you look at the geology map of Minnesota, Minnesota is covered with some sediment of like loess and some sediment which is not like it's prevent us to see geology. But once you have a very detailed like a magnetic survey of the whole state, it will just show us all the geology underneath, because the magnetic field is so different and contrasting. So by very detailed mapping of the surface of the state, which is covered by some sediment to prevent you to see the geology, allows you to see the geology and think about, oh, this is what actually happened. That suddenly it makes sense, right? Because you have some drill holes and say, oh, maybe you could do mining here, because we see that really sharp magnetic band here that indicate that there is maybe heated rock that could not only have an iron ore, but maybe also silver and gold and copper. So it's a really important prospecting tool.
And you were talking yesterday about how you can use this to find old buildings or ancient archaeological like areas where buildings were underground. Can you tell us a little bit about that?
Yeah, it is. For example, like recently we were in Africa and Tunisia, and we were there was a old ancient Roman settlement in a western Tunisia in Africa, and so what you can do, or what people in archaeology often do, that you measure not the magnetic field per se, but the change of the magnetic field. Basically, you have two sensors that are connected or separated apart, let's say, by 2 feet, and they measure the same thing, but because they are, one sensor is a little bit higher from the ground and one is closer to the ground, they can detect, any kind of a underground, like a magnetic hotspot. And usually when you have a buildings, like a wall, for example, of some archaeological dwelling, that specific bricks have its own, like a magnetic signature, and it's decaying with distance from that wall. And since you are walking above the ground, which is covered by some soil, you can often detect that specific decay from those walls of those buildings. And so this magnetic gradiometer is an excellent tool that you just put, like on your backpack and walk around over the ground, and suddenly on your iPhone you see, oh, there is actually a building here, there are some walls, and here's the entrance. And so that makes you exciting, because you would not know anything, right? You would see only soil and flat surface, but suddenly you see there is some structure that start to make sense.
That's fascinating. So what's happening is it's taking the magnetic field that's being disturbed underground, and it's not going to be flat, right? And it's mapping that. So it's mapping the magnetism, the differences between the wall and the soil, right?
It measures the hotspot, and the walls of the building are the hotspot that are modifying the geomagnetic field, and by this setup you can detect it. For example, let's assume that you have a just flat homogeneous surface somewhere, I don't know, in flat homogeneous loess, for example, soil. Right. And then you decide, I'm going to hit my treasure chest, right? My treasure chest would be, I don't know, banana. And I make a hole, let's say 1 meter deep hole, and put the little banana. But the banana is not important. What's important is that I will disturb the soil, and then put it back in a randomized fashion, and just this process allows me, to detect that there's a magnetic disturbance. That even though you flatten everything back like it would be like before, there is this magnetic perturbation that you have done, and you can detect that.
Great. So you don't need any metal at all.
You don't need any metal.
Yeah.
Yeah, and but you would still find that because there was a disturbance of that soil.
I know that you've done a lot of work with NASA before. Can you tell me a little bit about how you got started with NASA and your work with magnetism?
Well, it's always, there's an event that, my area was to look at the Labrador. Labrador is a region in Canada where they speak English, which was very fortunate for me, because my French is very bad. But there was a magnetic island, and people were thinking, why this is called magnetic island, right? And so there was some geology that showed that some specific rock, like a metamorphic rock, is really highly magnetic compared to the surrounding rock. And so that was my thesis that I had in Minnesota, and I had my a first presentation in Baltimore at the conference, and there was a table, and that's how I proudly put my poster there that I created, right? And there was a guy, like a little older gentleman, and he just had his coffee, and he just put it just almost touching my poster. And so I got really upset and said, you cannot do that. This is my first poster. I'm going to present it here. I don't want to be spoiled by your coffee. Put it away. I mean, there is a different table. You can use different table. So reluctantly, he took the coffee and went away. And then I put my poster up, and then he came back and looking at it, and magnetic fields. That's interesting. We also have a magnetic field on Mars, and we don't know what it means. There's a lot of it, and it's actually stronger than on the Earth, but no one really understands it. And this magnetic anomaly in Labrador, that looks almost the similar intensity. That's exciting. I mean, can you maybe you could help us. And so that's then we decided to write proposal to NASA that so I could be a postdoc at NASA, and that's how I started.
That's fascinating. I mean, I love that for many reasons. One is which you never know when you're going to rub elbows with somebody who's going to change your life. But give us like the takeaway. So you worked on that for a while. What do we know about the magnetic field on Mars? What's interesting about it? What are the mysteries?
Well, again, what do you mean by magnetic field, right? Suddenly, the magnetic intensity is like you would have it's much stronger. It could be like a orders of magnitude stronger. Like it was a Mars global surveyor mission that was using this aerodynamic friction during the orbit, so it used it for like a deceleration of that satellite around the Mars, but thanks to that specific way of slowing it down, the first measurement were able to be very close to the surface, because normally when you're on an orbit you are maybe like 200, 300, 400 kilometers away, but because of this slowing down you like dip your satellite into the atmosphere, right, and you decelerate it, and so it went on the other side out from the atmosphere, but this allowed you to go as close as 80 kilometers, and so people were just surprised, because the magnetic field almost like saturated their sensor in their magnetometer, and so they could not believe, was it some kind of a bad reading or some malfunction? But then it was repeating on a subsequent paths and orbits, and so this way they did not expect anything, because the Mars doesn't have its global magnetic field, so they thought they would find nothing. And because of that phenomena, that there was a very strong like a magnetic signature, we know now that the Mars in the past must have like a magnetic field, like a global magnetic field, but for some reason it disappeared, and it's not clear like why it disappeared. And also another mysterious thing is that the magnetic field is only on a southern hemisphere. It's everywhere, but on a southern hemisphere it's much stronger. And why is that? In a way, if you look at the Mars, there is so-called dichotomy, that the southern hemisphere is maybe 2 kilometers in average higher than the northern hemisphere. So people think maybe there was some giant impact or something that created this specific arrangement. But when you go down to the south, there's, for example, Prometheus crater or other craters, that the magnetic anomalies that are there are so strong that if you would compare it to the terrestrial magnetic anomalies, they are stronger than the terrestrial ones. So it's not clear, is it because of a lot of energy that took place in terms of some kind of a convection mechanism, or is it because there's a larger amount of iron, or is it a specific mineralogy, because we have people like to have a hematite like a necklace hematite thing, because it's shiny, and we found out that hematite could be so much stronger than magnetite. And so also by considering maybe the hematite is the one which is creating this specific phenomenon on Mars, but there are other hypotheses. So it's one phenomena that we don't quite understand. But second thing, it allows us to have a planetary laboratory, because if you have just these localized magnetic anomalies, and you have this solar wind that is coming and blowing around the Mars, there is an interesting phenomena when the ions are interacting with the atmosphere of Mars, because normally we think about northern lights and southern lights. There's this interaction of ions, right? But now that specific phenomena must be much more complicated, and I would like to understand that much more, because that's there must be some energy decay. And there was actually a mission that showed that there is this reflection of those ions that are coming in and out, and they use that specific reflection of ions to produce a new magnetic map that look similar like the one that was produced by this magnetometer.
Mm. I have to ask one tinfoil hat question here, because when you tell me about this crater on Mars that Prometheus, I think you called it, there's two of them if I'm not mistaken, but that you said that has incredibly strong magnetic anomalies. Like, if you were to be creative and imagine that you had a alien space thing there or something that was built in, like, would you be able to tell using like, would it show up on this map, or is that even within the realm of what's possible if you were to take that one guess and say, could you see it?
Well, this question has several angles. The first angle is that if you have a magnetized surface of a planet, and when you have impact like Prometheus, the impact usually gets rid of the magnetization. So it's like you have suddenly a hole in that surface, that you have a magnetization all around it, like a little circle, but inside you have an absence of magnetism. And so there's a large craters, like Hellas crater is one, Prometheus one, that shows very clearly that there's no magnetization inside the Hellas, or no magnetization inside the Prometheus. So in a way, it's an interesting tool, because when you think about it, when you have an impact, it generates a lot of energy and melt, and you would think that melt, would detect any kind of a magnetization of the field at the time when this happened. But the fact that these craters have this interior without any magnetism means that the global magnetic field of Mars was probably already missing. So that's one angle. Was that the angle that you wanted to know, or was
no, I'm just like, from a layman's perspective, you tell me like the first time I'm thinking about the magnetism on Mars, and you're talking about these anomalies, and I'm like, how cool would it be if we found an alien camp because of using magnetism on an Earth? And I understand that there may be lots more interesting normal science to it, but
when we were talking about it, we were mentioning the specific magnetometer and how does it measure, because normally, we live here 80 years, right, and die.
Right.
So there's a lifespan. And so if we measure something with the instrument, we need to consider, should we measure it like once every 5 years, or once every year, once every hour, once every second? And so the magnetometer that we use is measuring like a 250 times per second. So it's very quickly, right? In 1 second, you have 250 time measurements. And during that time, a lot of things can happen. And you talk about aliens, right? Could we detect the aliens? And so I have an analogy that we were investigating crater in Australia, Acraman crater. And so there are very spectacular anomalies over the center of that crater. However, because it's so remote, there is no electricity, nothing. We had to have an electric generator that was basically used to recharge our batteries for our drone that did the magnetic survey. But what I want to say that when we were doing the magnetic survey and when we were coming back to the generator, you could see that the generator was radiating out the alternating magnetic field, because the generator is producing just AC power. AC means alternating current, and that alternating current is just radiating this like a 50 hertz frequency out to the space, and you can, because your instrument can measure much faster than like a 50 times per second, like a 250 times per second, then you can detect that signal. So the alien, if it would be like two of us, right, running this survey, right now we would be actually radiating out to the space. Oh, we are here running the generator, and this is the signal of the generator.
So that's fascinating. So if I were to go out here outside in Alaska and go deep into the forest and dig a hole and set up a bunker and have a generator and then cover it up in such a way where you, from the outside, it's impeccable. You couldn't see me at all. And you were prepared with the right equipment and you scanned over it, you'd be able to find me right away.
That's right. And that's the beauty of it, right? Because once you have this power, like a household power, people don't realize, but when you are sleeping, you are always like irradiated by this field of 50 hertz, 50 times per second. There is always this like a magnetic field that goes, whoop, 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 you know, 50 times per second. And this instrument in your bunker would be doing just that. And so even though you'd feel, oh, no one can see me, I'm in this lead bunker and I'm buried. But since you would be running a power, you would have to be just a little smarter. You would have to create some kind of a magnetic shield room that the magnetic signal could not radiate out.
Okay, so there's a way to get around it, but you'd have to invest in it.
Yeah.
This brings me to another really interesting paper that you wrote, which has to do with the relationship between magnetism and the human brain. So can you give us a little bit of context here and help us understand what this was about?
Gladly. It's an exciting discovery, in my opinion. What it is that we are just creatures like any other creature that are using like a neural cell. And what I want to emphasize that iron is an important element, right? We have it in a hemoglobin. The hemoglobin is used for like oxygen in our blood. However, iron is also serving as a like little storage of excess iron, because normally each of the cell would like to have a certain like environment, and that environment is saying, I want to have a very specific concentration of dissolved iron in a fluid where I am. And in order to, to keep it constant, you have to have these like ferritin molecules or these storages of iron where you can put some more iron from the solution or take out the iron to keep the concentration level constant. And so normally when people live their life, when they are born, there is almost no very small amount of like a magnetic material or iron storage in the brain. But when you are aging, when you get 1 year, 2 years, 3 years, this concentration of these ferritin molecules increasing. And what we found interesting, that there is a very specific grain size that is being storage or stored in your brain. In those ferritin molecules, there is a magnetite, there is a hematite, there's also oxyhydride, a bunch of different minerals. But the magnetite is the one which is the one that we think is the most important. And the reason is that, so now imagine that you are sitting, right? And when you look at your head is just full of little compass needles. Like a little compass, right, that shows the north.
Right.
And so if you imagine all these little like compass needles, but you realize that there's something strange, that when you look really closely on that head with those compass needles, that every compass needle is fluctuating. That is not stationary like compass needle would be, but it's spinning. And that spinning has to do with the size, which is being as a part of this ferritin molecule. And we found out that if the size is like between 18 and 21 nanometers, what's nanometer? It's about 20 nanometer. It's like when you put 200 hydrogens next to each other. That's about the size that I'm talking about. So it's a small scale, and but the scale is important because this specific scale is causing the compass needle to fluctuate in a frequency which is identical like a frequency of like a brain scan. When you go to psychologists and when they measure the magnetic field of your head, they are usually detecting like alpha waves, theta waves, delta waves, and those waves have the exact frequency like the fluctuation of these little compass needles in your brain. And then we had also brains that had neurodegenerative disease like Alzheimer. And what was interesting, and that in those brains, there was a different size, because normally the people, when they have a normal brain, the size is always very similar. This ferritin molecule, where it stores that specific iron, always have the very specific size. However, for these Alzheimer brains, we find that the size was much, much bigger, that there was actually possible that the size was as big that it could record a magnetic field, similarly like a rock does. Like when you have a basalt, when it's cooling down, it records the geomagnetic field. In this case, you grew a magnetic particle in your brain to the size that suddenly the particle was recording the geomagnetic field at the time when you were, for example, in the bed. And it was remarkable that these patients that we got donated their brains later, they were bedridden. Therefore, they were mostly, on their back with their forehead upward. And so we could detect in those brains that the magnetization was pointing from their forehead backwards, parallel to the geomagnetic field. So in their brain, during their final stages, were serving as a paleo-magnetic recorder. And so that's that show that maybe the magnetite in our human brain is playing an important role. And I was talking about neurodegenerative diseases, but I want to also say that if there is a detection of these different waves, which usually are thought that they indicate a connection of different synapses, we ran a model and showed that the presence of these compass needle near the synapses is enough to decide if the synapses is connected or if it's not connected. So it looked like maybe the presence of these nanoparticles of magnetite are more or less involved in our thought process.
Well, that's fascinating. So let me see if I get this right. We have, in all of our brains, we have some magnetic material. When you're young, you have none, or when you're a baby, and then over time you have more and more. And then there's people with Alzheimer's, and you've studied their brains, and they have these much larger collections. I mean, it's still tiny. Like it's still, what do you call it, nanometers?
50 nanometers instead of 20.
Yeah, so maybe twice the size of what you'd see in a healthy adult brain, roughly.
Yeah, roughly.
And so and there's a difference between the size. So if it's 20 or if it's 50, it means that whether or not in the healthy adult brain, they're not going to be all correlated with the same direction. But with the unhealthy brain and the larger size, because of the size, they are going to be correlated with a certain direction. And then if I'm getting this right, you also talked about how when they're laying down, it gets correlated with a different vertical. So it's not only is it strange that it's all lined up, but it's also lined up with the brain that's laying down, vertical rather than if you were standing up.
That's correct. Yeah, you're right.
Okay, good. I mean, I'm summarizing partly for me, but partly for the audience, because I think it could be complex, and you explained it really well. But it's interesting to think about how we don't really know how it connects into the human brain, except for what you say with the synapses, which is the mechanism for it to affect human thought seems to be there. And then tell me about the helmets that you had, which I wore, right? So tell us about what these helmets are and why you built them.
Well, so the theory is we were talking about the synapses, and the synapses usually require a certain potential to get the signal. However, that signal could be noisy. And the reason why it could be noisy has to do with the fluctuation of those compass needles that are near the synapses. Because when you imagine that you have a rotating dipole near synapses, all around this little particle, there is a conducting medium inside the cell. And inside this conducting medium, you create electric currents. And the electric currents are basically raising the noise level, and therefore it can make your brain more foggy. that you would like to think about specific thing. I would like to think about this table, but you cannot pick up that word table because it's just you cannot figure out how is it called, this little thing, right? And because suddenly it's a little bit noisy, and that the reason could be that there is a certain frequency of these like a little compass needles that are creating the noise, making like a fogginess. And so we thought, hey, why don't we just put your brain into the magnetic environment? Therefore, you have a helmet, and the helmet allows you to have your brain in like a 2 or like 1,000 times stronger magnetic field than normal geomagnetic field. And this way, the fluctuation of those certain compass needles in the specific region in your brain suddenly would stabilize, because it would be stabilized by your helmet, because the helmet would create a much stronger magnetic field. And so suddenly, it's stable. You would know it's a table,
right,
and you would not have this fogginess. However, because we don't understand it so much, maybe you would not be able to think, there will be some other thing. So because it's a working progress, right? So we don't know. We think it could influence the thinking process, but we don't know if it would be good or bad, or how to take advantage of this knowledge. However, we created the helmets so we can, we just use them, but we haven't used them yet on Alzheimer patients.
Got it. Okay, so we don't know if it's going to be better or worse, but the theory is that it's going to do something. That's fascinating. I want to talk about another topic that we've had some conversations around and that you've worked on before, and that's the impact of the Tunguska over Russia. And so this was an event that happened in 1908. Can you start by just explaining what that event was and what we know, kind of the baseline, and then talk about your work with it?
Well, it was an event that happened in July 1908. And for example, people in Russia, because it happened in Siberia, think that was the most important event that kind of changed the way how at that time Russians were thinking about the space and rockets in space, because they knew that something is happening out in a space that can significantly affect the environment on the Earth, and so they wanted to understand it, and that's why they put a lot of effort into racketeering and try to figure out how the space is working. And so what happened in 1908? There was on 28th of June there was a solar eclipse, and what it is that people usually observe that there is a moon is blocking the sunlight, and so 2 days later, after this solar eclipse, suddenly there was a large explosion in Siberia. And it's a remote place, about 30 miles north from village Vanavara. And the people who lived in Vanavara, who were present at the time of this explosion, because they were exposed to radiation, that there was some two lines in the sky that were flying almost like horizontally towards the taiga, but the radiation from the burning and decelerating of this object was so high that the skin was like burned, and they got knocked out because there was a jolt of the shock wave. The atmosphere, once you decelerate, produce this shock wave, and the windows got broken, and so there was not clear what actually happened. So when they then later were trying to investigate this area in more detail, they found out that there's no crater, but that there is a little butterfly pattern, let's say like a circle, approximately 50 kilometers in diameter, and in that circle all trees were radially collapsed away from the epicenter. However, right in the epicenter, there was about several hundred meters of trees that were stationary. They were still standing. So in the center, you have a standing tree, but away from that standing tree, all the trees are collapsed radially out. So that was weird, because people thought first maybe it was a meteorite, and maybe they could go there and find like a meteorite pieces and maybe have a lot of nickel and use it maybe for mining, for the industry. But they were so surprised they only found these trees. And in addition, because there was these trees standing in the center, that was clear that there has to be airburst, meaning that there has to be some explosion high, maybe 10 kilometers in the atmosphere above the ground, and that shock wave was going perpendicular to the stationary tree, so they were able to withstand the shock wave. But as soon as you went to the angle a little bit away from that center, all the trees will collapse. And so because there was no crater, there's no like a meteorite material that would be found in that region, people were always like not sure what to think about it. There were so many different theories that maybe it was a meteorite, that was the most common one, but there was a lack of crater and lack of any kind of a meteorite fragment. Maybe comet, but if it was a comet, right? Comet usually always have like a dirty ice, and that ice would also leave some kind of a present that it's coming from extra space. Then there was ideas that has to do with maybe a mirror matter, which is like a type of a dark matter in the universe that people thought that must exist because of the of the physics, particle physics, that in particle physics you have a lack of right-handed weak interactions. So people thought maybe there's a dark matter, and dark matter have these right-handed interactions, and so this material, when it collides with the regular matter, create a effect like this. So then there were people thought maybe it was antimatter, and so there was a number of different theories. There was even, because they couldn't figure out what it is, they even thought maybe it was explosion from underground, that there was some kind of a kimberlite pipes that exploded, similar like in Africa there are these kimberlitic explosions that no one has ever seen, or it was some kind of a gas, accumulated gas, because this region is permafrost ridden, therefore you could have a slow accumulation of some gases that maybe could explode. But that would go against this evidence that people actually saw some kind of objects flying in the sky, and that would be hard to explain that. So there is a lot of mysteries. But what's interesting is that, well, we have a pressure wave that shows all these tree collapse. We also have evidence of the burning. And number 3, we have evidence of little microspherules. Normally when you have a lot of heat and burning, very often the metals like iron oxides are being is forming the microspherules, and these microspherules and even spheres that were almost like a millimeter in size, they were spread all over this place, even beyond this area of the collapsed forest. And so these are, I think, the only evidence, not only, there's one more evidence that I didn't talk about, and has to do with the magnetic field. Because Irkutsk is about 1,000 kilometers south from this region, and they had, brand new a magnetic station that were operating and recording magnetic field, and they detected that at the time of explosion, the geomagnetic field weakened about 70 or 60% of its intensity. Because they were just measuring magnetic field as a function of time right now. Suddenly the magnetic field weakened for 3 to 4 hours, and then it kind of went back to the normal level. So there was this evidence of magnetic field fluctuation that was not very well explained. And later, when there was a first nuclear bomb test, they found out that every nuclear explosion in the atmosphere has the same effect, that the geomagnetic field around that specific epicenter is going down for 3, 4, 5 hours and then go back. So the hypothesis is that this is the evidence of ions in the atmosphere. Ions is basically ionized particles that have a high conductivity, and that conductivity is shielding the geomagnetic field by producing electric current in that ionized cloud. And that's the reason, because you have a lot of these ions immediately after this collision, those ions are blocking the geomagnetic field, and that's why you see on the ground this dip in magnetic measurements.
What does that mean in terms of what it could be and what couldn't be?
Well, if we know that there's evidence of ionization, that is the most likely scenario that will explain the dip in the geomagnetic field. Ionization means that you have to have a stable ions somewhere in the atmosphere column. And atmosphere, usually we have the ionosphere that we know, which is very high, like 150 kilometers above the surface, that has a lot of ions, which is generally like naturally as a result of shielding against the solar wind. However, in this case, we are not clear where this ionized layer was. Was it like below the ionosphere, or was it part of the ionosphere? It's not clear. And there's no way how to say. The fact that the measurement was done in Irkutsk, like 1,000 kilometers south, suggests that it was something like a very large scale object of like an ionized cloud that would be spread at least between this Vanavara all the way to the Irkutsk. And so that indicates that there must have been some energy source which would ionize, which would bring the ions into the above that Tunguska region. But what could that be? So that's something that now give you the space for imagination, because a lot of people now can take these facts and work with them and try to figure out how can I make that ionic cloud.
Okay, so it's a bit of a mystery still. When you think about the Younger Dryas, well, first let's talk about what the Younger Dryas is. Can you maybe, for somebody who hasn't heard of this before, how would you describe the phenomenon of the Younger Dryas?
Younger Dryas. So a lot of people are curious about climate change.
Right.
And so people think, oh, now we have a global heating and the glaciers are melting and the ice caps are all melting. What's going on? Like, did something like this happen before? And so that's where the Younger Dryas comes in a picture, because the last ice age, when it was ending, there was a slowly increase in temperature. And so as a result of it, the nature was reacting to it, just, modifying its plants and animals. But then it's about 13,000 years ago, when the climate was really getting warmer and warmer, suddenly there was a cold spell. That suddenly the climate global temperature went down, and for about 1,000 years there was this ice age, like a return of the ice age that was there before, but it wasn't clear what caused that return of the ice age, because suddenly everything got cold and looked like that there was some event or some energetical event that stopped this warming process and put it back into the ice age. And so that's this about 1,000-year window is called Younger Dryas. It's a Dryas because when it's cold, when it's freezing, usually the air is more dry. And that's kind of associated with the cold. So even though it says Dryas, it means dry because of the cold. Does it make sense?
It does. What is this, 13,000 years ago? Is that?
It's about 13,000 years ago.
Roughly?
When there was this flip from, from becoming more and more warmer. You can imagine all these mega mammals that existed, right? And now it's getting warmer. And so they get all bathing suit, to be able to, waiting for the warm. But suddenly it was this cold spell. There are many ideas why it happened. One of the ideas that I like is that, and that's related actually what's happening today, that because of the warming, you are melting all the glaciers that are in the northern hemisphere, and also the ice which is in the North Pole and South Pole. And this means that you are putting into the ocean water a lot of fresh water, which doesn't have any salt in it. That water is lighter, meaning it will be floating on a surface rather than like a sink down. And it's normally the global temperature of the Earth is controlled by the convecting currents inside the ocean that goes from the equator go towards the pole and then back down underneath at depths, and this way they keep the same temperature. However, if you stop this by this freshwater layer on top, then you suddenly stop this convection, and if you are not convecting and not warming up this way the whole Earth, then that's one possible way that suddenly everything freezes. So it's one possibility that this stop of the global convection could trigger the Younger Dryas.
So what would have caused the global convection? It would just happen over time as the ice starts to melt, or do you think there'd be in this scenario, is there a trigger?
No, the global convection is happening normally. Like for example, today there is a global convection. However, it may happen that the water which is being melted in the north and south could stop this convection, and therefore, even though we are thinking, oh, it's really hot there, maybe you should get ready, that could be freezing. However, in the case of Younger Dryas, not only that there was a change in the climate, there was also interesting evidence that there was some cultures that were living in North America, like a Clovis culture, completely were decimated. That there was also a lot of mega mammals that at that time looks like they got extinct, at least in a North American continent and partially also in Asian continent. And so it appears that there was something that happened that also created this black mat, like a darker layering. At that specific time, there was kind of like a covering the surface of that specific sediment. And that black mat was rich in organic material and also charcoal, suggesting maybe there was some burning involved. So there is this theory that was suggested by Firestone in 2007 that maybe there was some kind of airburst or comet that caused that Younger Dryas. And the reason for that thinking is that when you, because everything is recorded in a sediment. So when you look in a sediment of the lake or the sediment of the ocean, and when you look at that specific layer, you found that there is suddenly appearance of these like a molten fragments, like a molten spheres like this one, and like in a micro scale. They are very small, but in addition there are fragments of glass that indicates really high temperature, sometimes temperature that melts even zirconium, meaning that the temperature had to exceed 2000 degrees Celsius. And this kind of go parallel with the Tunguska. That the Tunguska, that there was this explosion, but there is evidence of these molten fragments are occurring everywhere at that specific layer in this Siberian region. And so because there was this correlation, people thought, maybe there was something like Tunguska that happened at much global scale. But it's still in a process of trying to figure out exactly, was it a multiple of airbursts that could cause that? Was it just one single one? Or was it something completely different?
So to kind of dissect this a bit, and just as we're thinking it through, we know for sure that the climate shifted at that period of time, and that it was going from a colder phase to a warmer phase and it shifted down. We know for sure that there's these evidence of glass and the microspherules that in other instances we've associated with an impact of some sort. They may not be correlated, right? Or they may be correlated. And then also we know that there is a die-off of megafauna, and there seems to be huge shifts in like cultures, right? And so the question is, and I mean, the reason I'm walking through all this is because, you know, there's a lot of people that talk about the Younger Dryas impact theory, but I don't feel like there's a ton of concrete step-by-step conversations about, okay, well, what are the things we know for sure, and what are the things that we're speculating on, right? Because all of science, especially in archaeology, you have to speculate at some point if you're going to come up with these conclusions. Do you think that the evidence is compelling that there is an impact theory there? Is it still very much in the air? Like, help me understand how serious the science is today that this is what happened during that event.
It's a good question, and I'll be frank about it.
Right.
And so we covered like many lakes and other type of sediment. And so when you look at the sediment, you can age it by using a carbon-14, and you can find out exactly where it is, like where specifically it was happening. And there are sequences in both in Europe and also both in Northern America. And then before, in a normal lacustrine studies, people were not looking for like these molten fragments. But when you look and do like a very careful analysis, you find out like a no microsphere, no molten fragment, and suddenly there is an appearance of it. You don't see like too much of it. You see just there's absence, but suddenly there is per millimeter of sediment, you suddenly see that there's like several of these microspheres that show that there was some melting, unexplained melting that happened, and that somehow got into that lake sediment, and then it kind of like stops and go away. And in addition, there are in some other setting you have this black mat associated with these microspheres that show that there was some burning, maybe of the forest, or there was some fires somewhere that caused that black mat appearance. And so that's what you have as a data, right? You don't. Other than that, we can think maybe there are some other evidences, but how to tap it. We don't know if it was global completely, or if it was just focused on like a northern, like a North America continent. Because it looked like there are also some evidences from European lakes, but it appears that in Europe the evidence is just a little less or not as abundant. It could be because in Europe there is a more resistance against it. There is a lot of thinkers that were kind of classically thinking about this idea that there is the Younger Dryas, and the disappearance of the megamammals has to do with some specific, the models that they have in mind, and they just don't want to, give up those models. So that's my take. Does it make sense?
Yeah, it does make sense. I mean, it's interesting and it's fascinating because what I love to do is you look at the science and you think about it, and then you say, okay, well, let's use this imagination on top of that. Because there were people alive at that time. I mean, the Clovis culture, but people all over the world. To put this in a frame, 13,000 years ago, like we have caves in France that go back 36 or 41,000 years that are beautiful cave paintings that clearly show something that, like if a chimpanzee went and did the cave paintings in France 36,000 years ago, you'd be like, that's a special chimpanzee. That's a fascinating show of intelligence. And then you have much more than that. You have, what's the temple in Turkey that we were discussing?
Göbekli Tepe.
Do you happen to know, and I don't know off the top of my head, if that was before or after the Younger Dryas? I mean, it's roughly a similar time, right?
Well, it looked like that just to say what it is,
right.
And if you go to Turkey, the Tepe means hill. And so there's a lot of archaeology in Turkey because Turkey is known, that's like a cradle of civilization. And, the oldest culture that were present in Turkey were matriarchy base, and then there was a switch to patriarchy base, which is another interesting angle to it. But relatively recently, there was this discovered in eastern Turkey, this region Göbekli Tepe, and Stonehenge, right? People know Stonehenge from the England, like there are these giant circles made of stones. But in this region, Göbekli Tepe, there was 14 of them, very close to each other, and there was a very specific marking of like a different animals and different symbols that were shown on these stones. And in addition to it, there was a astronomical significance that it looked like that there was a specific arrangement that indicated different phases in terms of the orbit of the Earth around the sun. And even more interestingly, some of the features correlated with the astronomical phases that were more than 10,000 years ago. So people were really confused by that, right? Because people thought, the oldest culture, intelligent people, 5,000 max, and Egyptians.
Right.
And but then they find out that some of these circles were actually, there was some kind of a damage that happened, that they were broken, and the people try to fix them, to raise them and to make sure that the damage is undone. And so there was some plastering that had some carbon content from the period when they were fixing these circles. And that date, the chronology date, is about 12,000 years old. So that was a big surprise, because that was a very clear evidence that the fixing of these stone circles that happened after they were formed, happened 12,000 years ago, which means that the culture must have been existed before that. So so now there is a lot of speculation. What happened, right? It looked like there must have been like a clear civilization, because it looked like that there was a sign of really civilized pattern in this specific area that go back to 12,000 years ago. And so there are ideas that because there was this Younger Dryas, kind of a spell of a cold that was reverted by spell of the warm, because not only the change from warm to cold was very sudden, but also from the cold back to warm, the Holocene also appeared to be quite sudden. And so those are two different periods that are thought that may have affected this specific civilization. And maybe the fact that they were fixing that damage that happened has to do with the Younger Dryas impact theory, maybe. And that recovery of that specific circles, maybe the recovery when there was this return to Holocene, to the normal temperature. But I'm speculating.
Right. I mean, yeah, I think this part of it's definitely a bit of speculation. But I would say for sure what's fascinating is how absolutely massive this temple is compared to, compare it even to temples that we think of later. Or I'm saying the word temple kind of loosely here. We don't know what it was. I've seen all kinds of different theories about what it could be, but it's a monolithic, I don't even want to say building. It's a monolithic something that has carvings into it, has spiders, it has animals. It's significant, right?
And a lot of sex calligraphy.
Right.
Looks like there's a lot of thinking about man and woman, and when you create like a new baby, right? It looks like they put very significant importance to that specific aspect. So there's a lot of drawing that are emphasizing this part.
And this is I think, let me do the math here. This is more than twice as old as Stonehenge. This is much older than the pyramids of the Giza. This is really the first instance of something of this size. I think there's another temple nearby that was maybe arguably 1,000 years older, but it was smaller than what we're talking about. And I think that that's fascinating, because it's like, it seems unlikely that today we would be able to find the first temple that humans ever built. Like if we go back in time, and like, what are the chances that the very first one is still around, didn't get destroyed by thousands of years of future generations, and also wasn't, hit by something that wiped it out. But we have this very elaborate, beautiful construction. And it makes you think, okay, so then what were humans like back then? How how much of us today could we find in somebody that lived 13,000 years ago?
Well, I mean, there's books written on
Right.
this, and so, for example, Robert Schach is one of the leading authors who is trying to make sure that people are thinking more in detail about the civilization, and specifically that all these, it looks like religious sites are built maybe in order to tell the future generations something about what happened back then. That there is something that happened that we should really be prepared for if this could happen again. However, the evidence from those sites is by their tools back then, what they were thinking about it, right? And so I kind of like to consider this idea that maybe there's a message and there is some kind of a philosophy that we could try to see if there is any truth to it, that maybe there is some description of the event that took place back then in a long history, and then we need to be conscious about that specific event.
It's, I think, less than 5% has been dug up. And so it makes you think about the mysteries that are out there that are yet to be discovered.
And there's also darker side of it, because there's also the geopolitical thing, because we have many of these artifacts that are in Egypt, in Turkey, but because every country has its own kind of like a thinking, we should really prevent this our things. It's finding on our land, right? And we want to take advantage of it and somehow maybe keep it. And so I know that even sometimes there's a resistance against other nations to search for that, even though maybe other nations have better tools or more tools to figure it out. But there is resistance against, we don't want you here to figure it out. We want to figure it ourselves. So that's something else that also need to be considered if we are trying to discover things that are happening somewhere behind the borders.
That's interesting. And actually it brings up something I wanted to mention, which is your background is fascinating, because you grew up in the Soviet Union before that collapsed. And so I'm curious, what was that like as a kid, being in Czech Republic during the Soviet Union?
Well, Czech Republic. Well, for me it looked normal because I grew up like this.
Right.
But shortly to say, it's regime of control, meaning that you were a kid growing up, right? And as a kid, you have all these a freedom thing, and so you have a sense of adventure, but you were always cognizant that he's watching, or the parent of my friend is watching, and they can tell the teacher, and the teacher can tell someone else. So there was this kind of a complicated regime of controlling everything. And so that was kind of it's like when you are a bird and you want to fly, right? And but you are being like a bandit. Either you will you will comply, right? Or otherwise, the other possibility that you are just trying to really hard to get free, to be free. And so to me, it was when there was this Velvet Revolution, and I suddenly, felt now I can go elsewhere, right, and explore the mind. I don't need to worry that if I think this or that it would there would be some prick or some like a bad thing happening to me or to my friends. So that's how I feel it. So the age when I was growing up was kind of really in control of everything, and I'm really glad that I don't need to be under that control.
You on the way over here, you have this labs that you showed us yesterday of all the different devices that you had, and I was like, it must be cool to have all these devices to run experiments. Something comes up, and you're like, and I think what you said to me was, the only thing you really need is your brain, is your mind. And I think that's kind of a great representation of
That's true, because sometimes you have a lot of instruments, but if you don't really understand, the principles, what you are measuring, and what actually, the thing that the parameter you are getting, how does it fit into the picture that you are, in some kind of a mystery, then it's much better, just do something with your hands and create something really simple to get some data that okay, this works and this is really significant. Because very often, you get some small variation, but if it's not significant, then it probably doesn't matter. And that kind of comes back to the Younger Dryas, because all these evidences that we find are kind of small, right? We find these microspherules in a sediment. We find these like little itty bitty things, but it's not like something you would find something huge, like a big hole somewhere, a crater or something. So that's another angle that it makes it more difficult to fly with this Younger Dryas theory.
Interesting. So it's the nuance of it. You recently released a paper about three-dimensional time. And so I think that when people first think about 3D time, what does that even mean? And so maybe you can help us think through what was this paper about? What does it mean?
Well, about 3D time. Just imagine like a cube, right? And the cube is our world. And we think that throughout the cube, kind of homogeneously, there is this time that flow. And so in a freedom of thinking, sometimes you like to revert everything and to think completely opposite. So it was like a thinking, what if all what we are experiencing is actually some sort of like a universal projection or anomaly, right? What if it's, let's try to think about it the other way. So instead of 3-dimension of space, we have a 3-dimension of time, and we have kind of like a space that is penetrating that specific weird 3-dimensional time. And just start thinking about it. Like, I had like one talk in 2024 where at the last minute I said I will talk about 3-dimensional time, and everyone was kind of looking. It looked like a complete failure, because as I was trying to explain this idea, and there was like a very well-known physicist, they were thinking, the physicist talk was after me. He was said, "No, there's only one time." I don't agree with that at all, and that started his presentation. So it looked like it's a difficult subject to persuade some of my colleagues, but the idea is basically that what if space as we know it is actually made of time, right? For example, right now we are looking at each other, right? And we know we are existing in our like a time how we know it, but when you are considering this angle, it's basically every material, every mass, you and me are time anomaly. That anomaly means that you have some kind of you have a space in time, but that space is like a moving. It's not stationary. It's dynamic. There is actually like a motion of that space as it goes from the origin towards the future. And in that 3-dimensional space, if you, for example, are spiraling, have an object which is spiraling, suddenly you create a mass particle, and that spiraling is also associated with the electric charge, and those are like the basic items that we think that the space is made about. And so it's just a mathematical game or mathematical playground. Try to imagine what if the time has 3 dimensions, and once you went into the equations, that you start thinking, how would it actually work, right? And so in a reality, we have this problem between the quantum physics and kind of theory of relativity, this large scale versus the small scale. And so in this in the theory, I'm proposing that once you get to a smaller scale, that there is actually one of the other dimensions that becoming more dominant. Like in a quantum scale, you are not moving in terms of the time in that regular dimension that we know of today, but there is this now transferring into the other dimension, and therefore it could explain some of these quantum effects like dualismus, particle versus wave. And and then on the other end of the spectrum, when you go to like a large objects, like a galaxy size objects, and also very long time scales, then there is a third dimension that is starting to be dominant, which would be, and this allows you like to go quite naturally from this small scale that has one dimension of time into our regular dimension to the third dimension. And I liked it because, it just in one equation or one mathematical description, you could make this transition from the very small scale into the global, big, giant scale. And that was probably very interesting present I got from developing the theory, that suddenly I could see the connection between the small world, big world, and that everything could be made out of time. It just makes, I don't know, the more I think about it, it just makes better sense. And so what does it mean in terms of the physics, right? Because there are all these things that we experiment, that we are doing. There's a theory of relativity. There are these experiments that, about the gravity, Archimedes law. There are all these equations and constants that are present. But now, once I have this like a mathematical analogy or framework, I can use this regular physics to touch how the three-dimensional time look like, because we don't know how it is, right? How exactly, what's the shape that is responsible for the creation what we have here. So it's a process like a backward that I'm trying to use the regular physics, regular laws that are existing, and kind of touch something that I cannot really see, but I can how should it look like in order to be able to explain like this constant or like a speed of light.
It's a hard concept to wrap your head around, and I've done a lot of thinking about this since I read your paper. When I think about classical space-time, and I think about time as a dimension, I've thought about the analogy of like my life in the fourth dimension. So I'm kind of reverting back to the idea of string theory, right? Which is, if you were to treat time as a dimension, then, let's say the moment you could pick any time, but let's say it's the moment you're born, and then every frame of your life of you moving until the moment you die, right? So you're an old man and you die. And it's this long snake-like thing that follows you as you travel the globe and you get married and do all the things. And each moment in time is a frame. And that could be a way to maybe conceptualize the idea of time in the fourth dimension, treating that all as a single dimension. When I'm trying to think about time and the time having dimensionality rather than space, is there an analogy or a concept of how you could potentially visualize it that would help make it a little bit more clear? I don't know if you do. I'm just trying to wrap my head around it.
I understand. Well, the most what I'm doing, there's one assumption, and
right.
The assumption that I'm using in this specific concept is that you cannot travel back in time. So it's like this is assumption, like a number one. So all the mathematics, all the theory is based on this assumption, meaning that you start from somewhere from the origin, but since you don't have just one dimension of time like we normally thought, you can now go in all on this three-dimensional space, but you always have to go in certain, you can imagine some kind of a spiral. You're always connected with that origin, right? And you somehow move along this dimension, but then you move this way, and this once you have this kind of a thinking, or how it could work, then it's mathematically you can design like a projection using this existing space dimension, that how come that we express or we are imagining like a regular three-dimensional space, that that you can just, the world that we see around us, it appears to be as a projection using like this time, because everything that we see here is connected with the time, right? We know that, right? I mean, everything, we cannot like stop anything. We cannot stop time. And since we cannot do that, I think that allows me to create this kind of a three-dimensional time in which the space can exist, it looking like in three dimension. And as time go, I probably will find maybe a better way how to express it.
Right.
And but it's as I indicated, it's like it's a canvas, and the canvas, the painting that it's on that canvas is our three-dimensional world, but the canvas is made of three-dimensional time. That's probably the best analogy, right? That we see the space, but the space is just a painting on the 3D time.
Do you think that in this theory, does it leave room for the idea of free will, of being able to make a decision in the mind of, for our example, the mind of a human?
Well, it's free will
versus a deterministic universe where everything is a reaction to the moment before it.
I don't know.
Yeah.
It's the question is difficult because the world can be so complex, right? But who cares about complexity if you have a right mass and equations, and all the complexity could be put in, and it doesn't matter if it's infinite amount of possibilities. But the question is the determinism. So I think it's slightly like a philosophical question, and kind of also has to do with the diversity and how like everyone is different and everyone seems to have freedom to think about like a completely different direction. I also like to think about this concept of 3D time and different like scales, that it may be touching the way how we are thinking, the way of the consciousness. I know consciousness maybe is not the right word, but there is the things that are happening on a very short time scale, on a medium scale, and long scale, similar like in this 3D time theory. And the way how we operate, right? We have this, moment that we are kind of trying to react very immediately on something. Then there's this like a normal kind of reaction time that we are kind of moving, going to the bathroom, eating, normal time. But there's also this long range thought that we are kind of trying to revert our thinking in terms of the longer time scale. So looks like there is this play or game of 3 time scale that I see that each of us is using in order to think widely, freely about some stuff. And so I think it may have a impact maybe also on the development of the future artificial intelligence, that right now it looks like there's just like a one scale, or maybe transition of a few scales in terms of how the AI is reacting to the request of us. But I see that the future of these like a very different time scale of or loops that the AI would be using could be like a lead to that the AI would have its own consciousness.
Maybe it's some sort of emergent property of having multiple different, like basically if you can exist in the moment and have thoughts you can exist in the context of the day, and you can exist in the context of your life, that the collapsing of these three time frames inside of one cognitive unit is where consciousness originates.
I think you just said it. Yeah.
Yeah. Well, one that's fascinating. So I'm kind of breaking my mind on it right now. You've had the ability to go on a lot of very interesting adventures, everywhere from going to a crater in Bolivia to the Faroe Islands. Can you tell us a little bit about some of the adventures that you've had?
Well, I like the adventure in Bolivia. I mean, there's a image from the satellite. When you look at the image, it shows that there is a circle at the boundary between the jungle and the savanna. And so there was three expeditions that were sent to that specific area. The first expedition failed because it was time of the rain, like
the wet season.
The wet season, and therefore it was flooded, so they couldn't get there. Second time, they were able to get only to the rim of the crater, but they could not get in because some logistic that happened there. Third time, that was the successful expedition where I was also present, and there was a multiple approach. There were some boats that were taking like a river, that were going along the river to get to that area, but then there were also these helicopters, because at that time I worked for NASA, and NASA is a U.S. government organization, and in Bolivia there was a U.S. government kind of drug trafficking. So there was a Red Devil squadron run through U.S. government, and because of that U.S. government we were able to take advantage of this Red Devil squadron. So Red Devil squadron helicopters took us to the middle of the crater, dropped us there for a week and a half, and then came back for us. And so what it is, right? It's an interesting structure because it must have been recent, because it's in a kind of like an Amazon forest, which is a very, a lot of like a sediment. And it's just like a little dimple, which is on the course of 8-9 kilometers. It's only like a 20-meter difference between the center of that, like a dimple, and the rims of that structure. And so we were dropped in, and so I had my magnetometer. I was just going to the north, to the east, to the west, to the south, and trying to get the magnetic signature of this specific structure. And it was marvelous, because you just go through the jungle, right? You have like helpers that are cutting all the jungle, those plants, those little vines that have little thorns, and in front of you, and you are just stopping like every 100 meters, get the measurements, and try to get to the crater, because we thought maybe the crater would give us some more information. And then we were also digging the hole in the ground in like 1/3 of that little, if it's a crater, and from that we were able to get about 4 meters of samples of sediment that show, after we dated it, it looked like that there is a date that goes like 1,000 years, 3,000 years, and then suddenly all the other ages were homogeneous, like about 80,000 years. So it wasn't clear if it's because of the carbon-14. It's usually good only for a certain time scale, but it looked like that it must have happened somewhere, in recent history, up to maybe about 12,000 years or so. So we cannot discount that this crater could happen like maybe at the Younger Dryas even, or later after that, but not probably before. And so we have now the samples, and one thing that I would like to say is that when we were going to the center of the crater, right, there was an expedition. I went the whole day, and so there the Bolivian scientists like said, "Oh, look, there is a little fruit in this jungle, and it's yellow, right?" And I thought, "Oh, it's really good." And so I remember I took a few of these fruits, and it's okay. It's a little bit sweet, but it's okay. And then we got all the way to the crater, but then I didn't feel well, right? And I kind of like was sitting down and felt like I'm nauseated, and they saw it, but we reached the crater, so we were happy. And on the way back, they said, we will help you with your backpack." Okay, here's my backpack, help me. Because I felt tired. But as soon as my backpack was gone, I felt now much free, right? So I started to go ahead of the group, the three of us. And so I was now like more than 100 yards in front of them, and like happy that I can go, and I was okay. But then I look around, like maybe I'll wait here and wait for them. And then I'm waiting, and I see them in the distance. Oh, okay, they will be coming soon. And then I look, and they disappeared. And so, what happened? Where they are? And this was the region where there were these grasses that had these silicon teeth. So somebody was really difficult because it cut through your clothes.
Right.
And so I was because I didn't feel very well, so I didn't want to injure myself. But I went where I saw them, and then the way how you orient in a jungle is that you are looking for the cut vegetation through your machete, right? So I thought I was following those machete cuts pretty well, and that's where I decided to wait for them because I felt tired. But then they disappeared. I went, and then when I got back, I knew no one was there. So what happened, right? They thought that they were following the right way, and I went away from the right way, and so they were trying to catch up with me,
right?
But they went away, and so now I was there alone. And I remember I didn't know what to do because I was thirsty, and I kind of felt a little bit nauseated. And then I thought, maybe there's a little dimple. For some reason, I saw like a little dimple, and I thought maybe it would be good if I just lie down a little bit, maybe sleep. And then there was these pockets of water in some of those leaves, banana leaves or some leaves. So I thought, at least there's a little bit of water, because all my water, everything was in my backpack, and they took my backpack away from me. And I had the GPS, but I wasn't sure if I can, because there was a lot of canopy above me, so I could not get the signal where I am, so I could orient myself and just to go on my own. And so I thought I want to sleep a little bit, maybe half an hour. I just want to go down and try to sleep. And so I was worried a little bit about because these ants, these fire ants that we saw in the other day, that they were just going through the ground. There was tarantula, and the tarantula chose to go into the stream and sunk in the stream rather than to try to go through that army of ants that were going through the ground. So I was just hoping that the ants will not be there. And so I lay down and maybe slept for 15-20 minutes, just refreshed a little bit. And then I opened my eyes and tried to think, what do I do? And now I saw these two birds above me, right? And I kind of tried to focus on what it is, and there were two vultures, sitting on that tree. And I thought, that looks serious. They think maybe I will be their food. So I got really scared at that time. And I, decided to try. I saw there was some like a little less tree, so I went to that place and said I need to figure out how to get where am I based on the GPS. I know it's Garmin 4 old GPS, and then I was able to find myself. So then I actually, after a while, I saw the cutting from the machete. So I was going all the way to the boundary between the forest and savanna, but then I was tired, so I just sit down and decided to stay there. And in the meantime, the two guys that were with me went to the camp. They find out I'm not there, so they were coming back, and that's how they found me on that savanna
Oh, good.
forest border.
That's quite the story. So you guys had to take a helicopter out there.
That's right, yeah.
Yeah. Were there native people in the area? Were there tribes? Was there anything like that?
Well, the helicopter looked scary because there were probably 2, 3, or 4 places in a helicopter. There was a pilot, maybe another person, and 2 other people. But most of us were just sitting. We had the little belt, and our feet were just hanging down from the helicopter, and we were on the side. We were not inside, but outside the helicopter. We just buckled to the helicopter, and around it there were these machine guns that were all with the live ammunition, so it looked really scary. We saw a few fires when we were flying in, but then we were following the meandering river. But it was very
so who knows?
Memorable.
Yeah, maybe there was some people out there.
Well, it was interesting that when we actually started to, board the helicopters, there was a Spanish-speaking guy who said, "Oh, I've heard there is someone from Czech Republic," and he started to talk to me in Czech. And so I was surprised, right? How come that he knows Czech?
Yeah.
Okay, my mother and father was Czech, but I never been there, but I know a little bit. So it was an interesting scenario. Just before boarding these helicopters, there was this, in quote, someone who was coming also from Czech Republic.
That's amazing.
No, he wasn't coming. His parents were, but he was from Bolivia.
Czech Republic is a beautiful place. Prague, I used to live in Prague for a while, and I have to say it's got to be one of the most beautiful cities in the world.
Well, I like it. And if you want to know more about it, read The Secret of Secrets by Dan Brown, because I think it's a good book about Prague.
Yeah, absolutely. Well, what advice do you have for somebody who's heard this story and is like, wow, it's incredible science he's done. I love the fact that he's following his curiosity. Like, what are some of the principles or ideas that you would suggest to somebody to be like, hey, how you can follow a life kind of like that?
I think art, because a lot of time, you hear that art and science do not go well together, but I think art cannot exist without science and vice versa. So even though, we start painting a picture or drawing something, as soon as you start drawing, your hand is suddenly, inspire your thinking, and suddenly you will create an image that inspire you. And but then it's also a matter of focus, right? Once you have this kind of idea or inspiration, you need to put a tremendous focus into figuring out, the detail, because people say the devil is in the detail, right? But very often you can figure at least a little bit things out and then write about it and maybe speculate there may be 3D time out there.
Well, I think that's a perfect place to end it. Thank you so much. This has been incredible.
Thank you.